Hello and welcome to the very first video of the series Understanding Pointers in C. I am Dr. B.S. Satpute. In this video, we are going to discuss the structure of the computer memory. So let's get started. In order to understand the structure of computer memory in very simple terms, we are going to consider an analogy of a tiled floor. So this image which you are able to see here, imagine this is a tiled floor. This is a floor made up of tiles. This is a tile, this is another tile, so on and so forth. There are many tiles here which are making this floor. We can number these tiles. I can give number 1, tile number 2, tile number 3, so on and so forth. We can imagine our computer memory very similar to this tile floor. We can imagine a RAM or computer memory as a giant floor which is made up of these kind of tiled structures. Right? Let us imagine this is a RAM, this is our RAM or computer memory, and this is made up of these structures. These structures in computer memory are called as byte. One tile in computer memory is called as one byte. This is one byte, another byte, so on and so forth. So there are many bytes. There are many bytes which make this computer memory. Now, as we can number the tiles, we can also number these bytes. We can give numbers to these bytes. But numbers here are given in hexadecimal number system. So this byte will get a hexadecimal number, for example, ABD3, just an example. This byte will also get a number. All the bytes will get these hexadecimal numbers. These numbers in computer memory are called as memory addresses. Every byte has a memory address. This is having a memory address. This will have a memory address. This will also have a memory address, so on and so forth. Now, we store data in these bytes. Whenever I want to store something in computer memory, I will demand memory and I will be given memory in terms of bytes. Right? So now the question is, how many bytes are required to store data? So the number of bytes required to store data depends on the type of data which you are storing. For example, if you are storing a character, you will need 1 byte in C programming. So let's see how many bytes are required for each data type. So if you want to store a character on most platforms, will require 1 byte of memory. If you want to store a integer type data, you will require 4 bytes of memory. So when I want to store an integer, I'll be given contiguous 4 bytes. I'll be allocated contiguous 4 bytes. Right? So contiguous 4 bytes of memory will be allocated to me, and I'll be storing integer value there, for example 10. If I want to store a character, I'll be given 1 byte. I'll store a character there. For example, if I want to store A there, right, I'll demand 1 byte of memory. I'll get that and I'll store this A here. But I'll not store this A directly. First, I'll see the ASCII equivalent of this A. ASCII value of A is 65. So that 65 will be converted into binary equivalent. So 01000001, and then this binary will be stored here. Right. So that is how data is stored. Whatever you want to store in computer memory, that is finally converted into binary equivalent, and then that binary representation is stored in computer memory or in bytes. So now let us see what are the memory requirements for other data types. For example, if you want to store a integer float type data, you will need 4 bytes of memory to store one float. For example, if you want to store 10.4, I'll need 4 bytes of memory. If you want to store double type data, you will require 8 bytes. Right? And pointer, what is pointer? We are going to discuss this in great detail in the coming videos. So for storing pointer on 64-bit machine will require 8 bytes. On 32-bit machine will require 4 bytes. So memory requirement also depends on the architecture, whether it is 32-bit machine or 64-bit machine. So you can see these three data types have same memory requirement on 32 and 64, but pointer differs. Right? Pointer has 4 byte on 32 bit and 8 bytes on 64 bit. So that is the very simple view of thinking about memory, considering it as a tiled floor. Right? Memory is formed from these from this tile-like structure called as bytes, and every byte has an address. Whenever we want to store data, we will demand memory in terms of bytes, and once we get the memory, we'll store the data there, and the number of bytes required for different data types are different. So that's it for this video. See you in the next video. Thank you.